So I was at the point of trying to describe what I think this resistor here is doing. If you look at this, I suspect it's going under here and going to the output on this. I think that the clock is coming out through this resistor. These pads here are joined. The point here goes through to the other side and goes to that AC74 that doesn't appear on any of the schematics. I can only guess that maybe the clock here, yeah, the output of this, is going into that AC74 on the underside of being divided down, and you can either pass the clock straight out, maybe to the FPU, I'll measure that next, or you can have a resistor here and have it divide by 2 or something. In fact, you might, I don't know, thinking about this, that can't be just the route it takes to the FPU. Maybe that's the actual output, I don't know. I'm going to have to measure, I think, from the right side here to see where this point here goes to ultimately. But it seems strange to me that you would have something, presumably the crystal here, coming through that resistor and then joined to the same pin here. You know, it's not a pull up, pull down. This is going the same place wherever that goes, and it goes to a wire over here and comes up under the board. But this side here is coming on the output 2 of the 74 AC74 on the other side. So it's got to be something like dividing the main clock down to get a smaller FPU clock, you know, divide by 2 or divide by 4 maybe. Yeah, when I saw that AC74 on the underside, I was thinking about it, thinking, what's he doing? What's he doing? It's underneath this crystal here, 50 megahertz. The other guy who built one, there's only one web page if you search of somebody who's mostly built one of these. He never finished it. Well, he didn't update his blog if he did. And he used a 48 megahertz crystal, which is a bit weird. And the bill of materials does say 48, but it says 50 on here. This just relates to the CPU speed. That's the CPU. But I started thinking a 7.4 flip-flop underneath. Maybe it's dividing down one of 2 things. E-clock. Now I did follow a trace. It went all the way up here somewhere. And I was thinking, is it going to the E-clock? I don't think it is. I think it's the FPU clock. If you measure over here, look, dead short. Yeah? From either side of those 2 resistor points. So I think this has got to be an optional thing. If you've got the resistor there, I suspect that's going to feed the 50 here straight to the clock pin. Assuming that is the clock pin there, I need to check the pin out of that, but I'm guessing that's what it's going to be. Or you don't have that one, you fit one here, and I reckon that's going to be divided by 2. So I reckon we'd have 25 megahertz going there. We can test that when we build this, you know, well, we're building it now. When we get it up and running, when we power it, in theory I could probably power it now with nothing else on it, and we could measure here and we'll probably get 50, and we could measure the left pad of the one that's not fitted there and probably get 25, I reckon. Could be wrong, but we'll do that as one of the first checks, you know, when we do the burn test. Funnily enough, it's got a burn-in sticker on there from the 500 plus. I'm going to leave that on there. We'll stick a red dot on it when we're done, when we've burned it in ourselves. But we aren't that far off that point, to be fair. I was going to look at the power supply next. I've got something here. I'm going to create a power supply. That might be a separate video, but I'll do that. And then we can power this as is, see if any of the caps explode, have a measure around, make sure we've got 5 volts on a board like this. I would do it. You don't see me do that very often on small upgrade boards and things like that, but on a board this complicated that has very little in the way of support, I mean like no support, unless I try and find someone else who's built one of these and happens to have built the same revision, I'm going to get no support on this at all. I don't even know whether George is still around anymore. I don't know. I haven't seen anything from him in recent years, and this was 2018, remember? It's like a tuning fork, this. It was on the table before. My multimeter was beeping, and because of the vibrations going through this, my multimeter sounded really weird. Yeah, so I would check for not just shorts, but make sure we've got 5 volts in every single one of these things. But we need to get a load more ferrites on before we do that. I can get that on next though, so I'm going to do that. I know I said a few minutes ago that I might leave that off. I'm going to put that on now. And we can do that as one of the early tests. You know, we power this, yeah. And we got the chip here, maybe none of the others, apart from Magnus, maybe, just so we can get, you know, clocks and things going. I can then have a look at the chip enable and output enable, you know, chip select and output enable on this. And just make sure it is disabled, and then we can maybe even try the jumpers and see can we enable it. Now I think I've got some 27C4096 ROMs, EPROMs, that came from one of the amazing guys on my Discord. I think it was it TRU? I think it was. So I might be able to get a kickstart onto one of those, I think, and use the 4096 profile. last tantalum on here now. Yeah, I've spent about, I don't know, 3 solid days I reckon working on this over the space of a week or 2. Crazy about solder. Cav tweezers to the rescue. And a little bit of moving around just to get it just right. I don't feel that's just right. Very few components left now, just waiting for inductors mostly. Yeah, I needed a 7.5 picofarad. They didn't get us a 6.8, but just measured it at 7.2. This is what I figured. So you know what? That's not going to be far from the mark, is it? I think that should do. That's for down here for the PLL. Worst case, if that doesn't work, I'll get a 1 picofarad and stick it on the top of it, because that's where they add up. You know, you add a 1 and a 6.8, you'll get 7.8. At the moment we've got 7.2, but with temperature variations and things, it might go up and down a little bit. That's the thing. But I think that'll be all right. I keep thinking I'm so close to the end, but I'm actually close to the beginning of the debugging process, I think, and testing things. But I don't even know whether that 50 MHz crystal works. We may need to swap that 50 for a 48 yet, because I think the bill specified 48. And I think that 50 came from one of the 4000 tenable fireboards actually. It was one where I thought it was faulty. And after the event, I actually had the crystal set aside. This was like months later, and I thought, let's check it, and I checked it, it worked. So I actually think it was the crystal, but it was the crystal socket on those 4000s. They go into a socket. Yeah, just cleaning up around those 2 chips there. And we got the trim cap there as well, which I've fitted. So technically, again, it's another one of these, it's not quite the right part. It's like 2 to 10 or something. It's supposed to be 1 to 5 or 1 to 8. But I know from experience that that will do the job. I use one of those to fix Tom Mead's scan doubler, and it uses the same chip with more or less the same component sizes and things. You know, it's a lift and shift almost of the scan doubler on the 3000. Because the position you're going to need to set it is probably somewhere like 3 or 4 picofarad. In fact, it starts at 2. It's not really a big problem. Still got a number of things just pinned around here, and I'm leaving them that way just until I've got the chip RAM on. And the chip RAM has arrived, so I might do that next. I don't know. Got tons of RAM to put on it, and I got all those Cypress ones as well. The chip RAM though is that SOJ, you know, or SOAB as I like to call it. Create our little mask. Yeah, so all the stuff around here is just kind of temporarily pinned in place, but if you look at the 2 chips we've just done here, look at that, nice and clean and glossy, and the trim cap there. And if I had £1 for every time I put IPA in a cap and then knocked it over, I may as well take advantage and clean my tweezers, haven't I? Thanks to Commodore for those. It's kind of convenient actually, because it does get onto, you know, flux gets onto all of my tool handles, so you know what, I'm just taking advantage of that and cleaning them all up. Right, let's get the DRAM on. So, yeah, there's a seller of this in the UK. I managed to buy a load of it, look. And it was dead cheap. I couldn't believe how cheap it was. I might buy some more of these, they're so cheap. I mean, it was like, I don't know, £5-6 or something for like 15 of them. It's a bit of an odd number. Sellers always do that. Don't do a divide by, you know, 2 thing and then the one short for 16, you know, so yeah, I might buy another one. Anyway, this RAM, wrist strap is on by the way, is Toshiba TC514400 ASJ-70, 70 nanoseconds. It's new, old stock, never used, solder, no solder on the pins. Pin 1 is up here. Yeah, I hate these SOJs, they can be really hard to solder on. I think we're going to be alright though. I think I'm going to be alright. So I'll bring the microscope down, I think. just to show you the first one, but to be honest, you're better off using a magnifier and looking at it sort of 45 degrees on, you know, side on. And there might just be enough space to get the iron down the sides and in between these, rather than have to mount them with hot air. And if we just had a micro adjust this around a little bit. Yeah, the nice thing with this is there's enough space on the pads. Look, when you've got that much space on the pads, as you drag solder, it flows a lot better. Some of these I've seen, let me show you. If you look at the left hand side, some of these I've seen where it's like that, like right over the top of the pads. Yeah, and you're like, oh my god, how am I going to solder that? So this is actually a pleasant surprise, that the pad spacing or the pad size is quite large, giving us well, more space to get the iron on. It's hard to see whether that's soldered or not. Right, that's the chip RAM soldered on. You can argue you should really check voltages before doing that, really. But we can cautiously check the voltages. But we're a long way away from that at the moment, you see, because we haven't got the ferrites on. I mean, I could bridge with 0 ohm links or solder blob or something. You know, it's like down here, for example, the power comes in. It's not getting to the board, and the areas of the board that are, you know, are separated with the ferrites there. You know. Gals have arrived, some of them. So I've got some Dash 15s, some of the larger ones, the 20 V8s I think, and the 16 V8s. So anyway, and we got some sockets. There's a few more sockets I've fitted here that need soldering on. They're just anchored, I think. These two need soldering, I think. But these arrived. So I've got 68030 socket PGA and the 68882 or 68881 PGA. Those have arrived, just stuck through, not soldered on. Thanks to Sparks UK. Trying to source those. What I ended up doing, he suggested buy icnow.com. So I've got a couple of these. So I've got some for another board that I'm building, because I'd run out of these, and these are really hard to find. They were expensive, like, I don't know, £3 each or so, might even be £4, £3 each I think. So yeah, it's hard to find these. If you know where to get these cheap in bulk, please let me know. I'd like to get, I don't know, 10 of each or something, just to have a stock of them, because well, they seem to be getting hard to find, and it's no wonder with all of the terrible fireboards that have been built. It's like, I think of how many I've built myself, you know, in my collection here with these sockets on. Yeah, they're starting to get low in numbers. But I think these are newly made. They look like they've, you know, been freshly made. I know Goose 3D printed some frames, didn't he, for 68030, so I don't know whether he's got anything we could use or something like that. Because you can get the pins separately, and you can just pin your own socket if you can 3D print or something like that. You know, a frame. Anyway, I'm going to anchor this in position. Yeah, that was my door. I think there's more parts for this actually. Got 3 more little jiffy bags there. I'm hoping the programmer's going to be here soon for the ISP chip, you know, Lattice. Anyway, so I'm just going to anchor these. And yeah, I've checked the profile, we've got a pin in every hole. So I can solder those on, I can solder these 2 on. Let me just see what the other bags are that have arrived. Right, what have we got? Ah, we've got the resistors. So I've got the resistor. It's one of the final individual components that are missing, you know, for the PLL here, 1K. Trim pot. There's 2 different profiles. I don't think I've got the exact profile, but I think that should fit anyway. So I've got one of those we can stick on. Don't underestimate the cost of parts building a board like this. I don't know what how the EATX boards compare, because, you know, those have got a lot of components. This is more stuff for this, isn't it? Is it sockets? Yep, there we go. This is really good. I've got the things I need to finish off here, because I need some of these larger, I think the 24 pin, aren't they? And then I did get some of these, which I, since in retrospect, realised I didn't actually need these sockets, because I've got quite a few. But anyway, we go through them a lot, the 20 pin sockets. Can't believe they ship them in a bag like that, because this is when you get bent pins anyway. And then we've got this. Is that going to be a programmer? Please be the programmer for the Lattice. Yay, it's the programmer for the Lattice. USB ISP download cables. So we can have a go at programming the Lattice. Do you know what? I think actually we've got potentially everything here, apart from maybe some slower gals, to finish this. It's just finishing it off now. It's just getting all the last bits on, programming the bits up. I'm so excited. Let's just get that resistor on whilst I'm here. Yeah, you can see what I mean here. They've got 4 pins. Yeah, there's one that's offset, and if I inspect this from the top, yeah, the middle 2 pins are joined together, so it doesn't matter whether you've got the one that's got the pin offset or the one where they're in line. It'll accommodate either here. And bear in mind, with a variable resistor like this, you know, a trim resistor, unless a trim cap, when you adjust it, you change the resistance. You know, the centre pin is your common point, and you change the resistance from the right all the way to the left. Yeah, so your resistance, you know, goes that way. So I think we can literally just put that on there and solder that on straight in line, ignoring the fact that we're not using the, you know, the other pin. Because some of those you can get that have got either the pin staggered or it might have 4 pins. You don't need 4 pins at all. Yeah, we'll clean up the solder points on that in a minute, but that's one less component to deal with. I may as well anchor those in the sockets while I'm here, haven't I? May as well get 2 of these larger ones on. The one here, not fitted yet, just because I'm waiting for the ferrites. When the ferrites arrive, I can fit a ferrite there, and then fit that socket. It's just giving me a bit of clearance. You know, I could technically fit the socket and then just work within the gap, but I prefer to make my life a bit easier with that and wait for the ferrites before I fit it. All the other ones we've got good clearance to do the ferrites and things. And I guess something else, I've not fitted the strips here. I've got them cut to size, ready for the hybrids to make them modular so I can plug or unplug them. But again, I'm not going to fit those until I've got these inductors here fitted. And they're all the way along here, look. And I do have these as well. Again, I'm not fitting those. In fact, I could fit that. Yeah, we've got a capacitor waiting for there. 220 microfarad tantalum. So yeah, I did order a couple more tantalums just because of clearance there. I can't fit 2 through holes, or not through holes, can type, you know, electrolytic. With this particular board, there are tiny vias next to these points, so you've got to make sure you don't accidentally bridge from a via that's not supposed to be soldered to the pin, if you see what I mean. Yeah, so those are darn straight there. All the pins are through, so those can be soldered as well. I'm so excited to get near the end of this. And then no doubt spend hundreds and hundreds of hours trying to debug this flipping thing. I mean, the thing is, I wouldn't know it's like if I get the code onto this ISP and it doesn't boot, I'm like, is it the ISP? Is it something else? Is the code the right code? Is the crystal right for the speed of the code that's on the, you know, the ISP chip here? Is it one of the gals? See what I'm trying to say? There's going to be like an infinite number of variables, including jumpers. Looks immaculate, doesn't it? It's looking pretty good around those 2 chips there. So overall, the board is looking incredibly shiny and glossy. It's just the odd fingerprint. Anyway, we are so close. Right, so you saw me program those up there. There was one point at the start we got an error, the voltage of VPP was too high. Previously from trying to get a chip that wasn't working, and that does work. Sometimes when you go up from 13 or 13.5 volts to 15, 16, 14 even, it'll program, even though previously it wouldn't. You saw the issue with the last one there, that it's all zeros. I don't think it's used at all. We'll try that later. If we get this up and running, we'll take that gal out, 56 I think it was, and I bet it just blooming works. I mean, the zeros technically mean the bits are set, but then all of them are set, every single bit was set, which makes me think that gal, wherever it is, something to do with the functionality to do with switching the ROM over, you know, this here. That never got done, you know. There was like, because it supports 1 meg, that you can have 2 halves of it, and I think the author said at some point there'll be an update to this code here and an update to one of these, which will get the second half of that 1 meg working. And I think that's why that's blank. I think it was just never done. So anyway, we can have a look at that. Let's say try it without it. These chips are all reclaimed, you know, China specials, solder coated, jet black tops. You know, I was having problems writing on them, which means it's painted. So you know, are the GAL 15s, the Mark 15s? A lot of these are 25s, you know, so this could be an issue here. They need to be 15. So I don't know. This is one of the issues I might have. So that one's 56. That's 53. That's 54. That's 55. So let's put that at 56. So I've got 53 here. Going to need to straighten the pins, so we'll use Cather's leg straightener here, and see how we get on with that. Let's just squeeze. Yep, that's pretty good. And one of these had a little bit of corrosion on one pin. I'll show you that in a sec. The point where you saw an error where I was verifying, what I did is I verified all okay, and then I swapped to a blank chip and just click verify again, just to make sure the verify process was actually working. It's something to consider doing when you're programming chips up and testing 7.4 series. If you test the 7.4 series and it tests alright, put your next, you know, different family 7.4 series in and just hit retest, and you should get a failure. If you don't, you know something's going on, you get a false test where it's just passing everything regardless. And yeah, I like to call its bluff and do that, you know, verify against the wrong code, for example. And you could argue what I was going to do that I'm not doing here is to explosive test it, you know, make sure the power rails are right before we stick these in. But I figure there's just so much to do here, it's not going to be a big deal leaving these things on for the first power run. But I will not get, you know, I won't have the main chips here. We'll just leave the 1 or 2 things that are in the dip sockets and see if we get any caps exploding. So I think this is the one with the corroded pin. You see it there? If you look at that in the light, can you see that? It looks black. So I'm just going to clean that up with a fiberglass pen. So anyway, that's 4 down, and those are all 20 V8Bs-15. That's what it's supposed to be. And I think we've got a load to go over here, haven't we? We've got some GAL 16 V8s. So I'll do those ones next. I thought there were some 25s somewhere that need to go on this as well. Right, so uneventful programming of these. I didn't show you that. They're just the same thing. You just select the GAL, you know, it's a 16 V8. I've got a few of these. V8Ds, which are 25s, V8Bs, which are 15s. Now we got 6. So I had to pay close attention to make sure that encrypt was unticked. The lock bit is unticked on each one. And as you change the GAL type, if you've loaded the JED, it blanks the JED, so you then got to load the JED again. And make sure that I've got the right speed chips here, -15s or -25s according to the JEDs. Anyway, this one's marked 18. Got to try and find where U18 is, isn't it, or IC18. Right, and I'm taking a risk, but I'm going to get a load more 7.4 series in here. I've got the wrist strap on, but we haven't got much rework to do to this now. We've got the RAM. I'm going to wait for that as the last thing. We'll test this board without that. It should work without it. It's just going to complicate matters if we've got some issue with the fast RAM. Because if you've got fast RAM there, it will enable it, it'll stick things in it, and then if you've got a problem with it, it's not going to boot. It's better to just start with chip RAM and not have that RAM on the board. There's probably ways you could not have that RAM, like remove these buffers and then it wouldn't see the RAM. So there's a few different ways you could approach something like that. And there might be the odd GAL or something on here that controls those, so you could not have that GAL on there and then it would well, I don't know, strange things might happen, because if these buffers start outputting when they shouldn't do, you get problems anyway. I am going to just go for it and stick some of these things on. 573, and we haven't even power tested it yet, but anyway, I'm throwing caution to the wind. I'll try and find where the 573s are now. I think they're up here. So I think that's the data path up there, effectively. They've used different ICs than you might get on a 500, but yeah, I think that's what that is. So a lot of these ICs came from DigiKey, the ones I'm dealing with at the moment now with the 573s, but it was incredibly hard to try and find every IC for this. Some of the 74 series was not on DigiKey. You know, it's like end of life in DIP. It's like you're lucky if you find lots of DIP ICs with some of these manufacturers these days, or not really manufacturers, some of these you know, component providers. So I've got a load of 573s that can go away, I think. I've got some spares. It's 541. So I need to find the 541s next. Now, have I got those? Yeah, 2 541 74 HC 541s. It's old stock and it's not solder code, so you know what, that fills me with confidence that these are probably alright. They're not reclaimed, if anything, because they've not got solder on. So again, pin 1 is to the right on these. Doesn't really feel like that's in. I don't like the way that went in. Everything looks alright though, I think. And the sockets on this are very straight, but one or two of these chips, they go crooked where they go in slightly. So you can just do a bit of that, you know, sort of slightly, hang on, put a pressure, just to strain it out somewhat. So yeah, that's not too bad. Place your bets, do you think this is going to work when I first power on? I don't think it is. So I've got a load of stuff to go down here. Yeah, one or two of these chips, you can see, even though it's been in a chip container, and I think it was new, I think it came from DigiKey, maybe. Yeah, the legs are like grey on it. And yeah, it's just a bit of light oxidisation. They come up really clean with just a gentle wipe. That's it, they're all looking good. Yeah, so the other 541s, hang on a minute. Where's pin 1? That's round the wrong way, is it? No, it's not. Yeah, pin 1 to the left, pin 1 to the left. That's another 541. I'm concerned that I don't have all the parts here again, because there's some 521s, and I don't remember ordering 521s, but maybe I did. I don't know. Anyway, that's it. That's those in, 541s. Yeah, I think there's a 521 down here. I don't think I have a 521, you know. That's going to be a problem. Right, making up an adapter here now. So I've got some Vero board or whatever it's called here. You know, it's just a single pad for each 2.54 pitch thing in a matrix. Got a socket on there for the chip, the right pin out. I've got a connector here, an IDC 10 pin female for the JTAG cable, because you get various cables with this, and hang on, one of the ones is that, so I can use that. That'll make sense to do. I'm just going to cut the end of the board off here, stick a jumper for 5 volts and ground that will go to my USB cable I usually use with the Xilinx programmer. But anyway, I am just literally going to saw this. Yeah, it just makes it kind of presentable, and I'm not going to cut myself on it. There is a notch there, look. Right, there we go, almost like a bullet one. So I'm going to get a 2-pin header and solder that on there as well. Right, I printed off a diagram with the pin out. So pin 1 is ground. What I need to do now though is work out where pin 1 there goes to here on the underside. It's like pain in the bum, this. And touch the solder point. Yeah, there we go. So that's ground. I'll show you on the phone and thing here. So yeah, so pin 1 up there is ground. The one to its right is VCC. It does say top view here. So if you just trim 2 like that, that'll do for my pin header. I need for my VCC and ground. But it'll also do to test this now before, like, you know, if we stick it in 2 pins like, you know, that, we can see, are they shorted? If they are, they're the grounds, and they're not. So it's not those ones. Let's try the other side. Those aren't the grounds, which is surprising because it should be on the side where the stripers. If you look at those there, can you see that? The grounds are on the side where the stripers, and we've just checked those and neither of them are joined. So there we go. So finally found the grounds. I don't know what happened the first time. I don't know. Those two are joined to each other, which means that is the VCC in the middle. Alright, that should be it. I'll tell you how I wired that in a minute, but you can see I've got a red marking on the PCB there, black one, and my 5V ground. It's usually an old USB cable with a pinhead socket. Chip wants to go in here, and carefully push in. Wow, that's tight. Especially, you know, those pins look weird. Yeah, hopefully it's a good connection. So I've got a ground and a VCC at the bottom, a ground and a VCC at the top, and then we've got TDI, TDO, TCK, I is open, I think, or I is pen, I think it's as you put to ground. And then obviously the VCC and ground are joined up between all of these things. And I've quadruple checked everything. So, what's going to happen? I don't know. So I'm going to go and plug it in. First of all, I'm just going to just power it without the thing connected up to, you know, the USB cable. I think I need to use the service pack update or whatever it is to install a newer driver for Windows 10. Anyway, this is marked black, red, and it's just a USB cable because USB is 5 volts. That's not necessarily true, I think, with USB-C and things like that. I think, doesn't that negotiate a voltage? I don't know. This might negotiate a voltage, I honestly don't know, but I've always used it this way and it always works. So at this point, I installed the software needed to program this Lattice chip. There's more information a minute or two further into this video where I show you the programmer and I outline what you need to do in terms of the software side of things to get one of these chips programmed. Massive thanks to Stefan Scotti. He was able, through his contacts, to get me all of the files I needed, all the JED files, the schematics, a user manual, but it was in German. I used Google Translate to translate it to English. I'll cover more of that in the next part, I think. And all of the binaries and things, you know, ROM images, the Amiga side code that we need to run in the, you know, upcoming part, as you'll see. Anyway, massive thanks, Stefan, for that. I couldn't have built this board without you. Woohoo, I did it, and it was successful as far as I can tell. That was really stressful. I spent half an hour trying to work out what was going on. Initially it wasn't detecting it, and then I had to run, with administrator rights, the service pack, you know, for the classic lever or whatever it is, which it's just a driver, it's a newer driver for Windows 10. That installed, but it still wouldn't detect it. And I had the ispN on here, wired to ground, and you don't do that. It's on the chip itself, there's a pin there, ISP enable. If that's not pulled to ground, you can't program it. So that's all it was. It then did the boundary scan, it detected it as you saw, and I was like, woohoo! It was like jumping up and down with joy. And then, I forget what I did, you saw I attached a file, and a data file, and then selected the action as, you know, erase, program, verify, and then click go. And thought, is that it? Is that what you do? And then it worked, and it said it's complete, and it had a green light. So I think all is good. One of the pins on that just needs pushing down a little bit, but anyway, that has worked out really well, hasn't it? So it was thanks to Stefan for the idea. I already sort of had the idea, but he was like, you know, he proved to me that you can do it, because he was like, you know, I did it on a bit of board, and he stuck a socket on just like this. The interesting thing is, when I was Googling, I was trying to, just a minute ago, trying to work out why it wasn't being detected after I'd thought it should be. Guess whose article I found? I found Stefan's posting on EEV blog. Now, he pointed to an article that was to do with Atmel chips, and it was completely different pinout stuff, so that gave me no information whatsoever. So yeah, I couldn't use any information related to that. Nevertheless, I have managed it. It's an absolute bodge on the underside. So just to summarise, the centre pin up here is ground. To its right is VCC. That was a mistake I made earlier. I soldered there thinking that was VCC, and it wasn't. It was like another pin, I think, here or something below. And this is the thing, as you go along these, you're thinking, you know, oh, it's the pin next to it. It's not. It might be the pin below the one you were already on. If you, do you see what I'm trying to say? Because of the arrangement there. So anyway, so the centre pin's ground. The one to its right is VCC. The centre pin on the bottom here is ground. To its right is VCC. Those are both joined up, you know, so the ground's to ground, the VCC to VCC. And then up here, you've got two grounds on the bottom here. Yeah, so those join to the ground. They join to the ground on this jumper here. The VCC is the centre pin. So as you look at it here, hang on. Yeah, these are the grounds. That one there, the middle one, middle of that row there is VCC. Again, which joins here and joins the two VCCs. There are more grounds than VCCs. You could join those up if you want extra security and the rest of it. And you could stick a cap on here, 100 nanofarad and maybe a 22 microfarad or something like that, just to help if you're having glitchiness. But it worked fine for me, as you saw. And then, of course, you've just got TDI, TDO, TCK, and TMS, and I'll stick those up there so you can see which pin numbers to stick them to. Basically, it's like something like 8 from here is one of them, and then as you go along the bottom, it's something like 8 from one side, 8 from another, and 8 from somewhere up down here, I think. So you just end up with those 4 different pins, one for a clock, one for a, you know, a select signal, and then data in, data out. It's dead straightforward. It really is. I'm going to keep that now, just in case we need to reprogram this, because I don't know whether the firmware I've used is right. I mean, it said 60 megahertz. Now, if you look at this, I think it's a 60 megahertz red part, because it's a 60 there, I think. Here it says, yeah, 60 LJ is like a subcode. So I think that's what it means. I think it means you need a 60 megahertz flavour of this for that firmware. Yeah. Although it's not going to be running at 60, it's probably going to run at 50. And you know what? That means it's going to be better than running up to 50. You know, if you had a 50 megahertz chip and you're running it at 50, good luck trying to get that working. I mean, it could be wrong. You know, if something's rated for 50 megahertz, it would probably be all right. Yeah. Anyway, so there's just one pin there that just needs a slight press to the right, and then it's a little pin just pushing downwards a little bit. So yeah, they're a wee bit mangled, these chips. You know, I got a pack of 5 of them here, and well, yeah, they're just not the best. They're mostly okay, but I don't know. They look like maybe they've been desoldered for something, and 1 or 2 of them have got pulled or something. It could have been the way they were levered out. But anyway, that looks all right. So the software I used was ISP Classic Lever, I think it was. And I didn't need a license. Ignore the licensing stuff. For this family of chips, it just works. It just works. You don't need a license, thank God. Because that was my stress, you know, it's like going to be £500 a year to license it or so. I'm like, how the hell does anyone program these up? So, yeah, I'm very, very pleased with that. And you know what? I'm just not sticking any other ICs on this just now until we've done the smoke test. So I'll just stick that IC with the Agnes in this little ESD thing here. Let's actually stick it in that bag with the Agnes, because I'm sure this has got my Agnes that featured on my Vince's channel that ran on my 500 Plus for, let me get the strap on. Yeah, it ran on my 500 Plus for the last 3 years-ish, maybe 4 years. I'm trying to think what it was. It might have been before COVID, I don't know. I can't get it in there. I figured, why not put it on a board that I'm using all the time? Because, you know, this board is going to mean more to me than the 500 Plus that we test with frequently. And I'm sure you get sick of me saying that when that 500 Plus appears. Like, with the chip from Vince's channel, look, you can see, fix the pins on there. So that still works really solid and reliably. We will get that on here once we're ready. But like right now, as I say, I'm just going to just put it back in the SD bag. We'll wait until the ferrites arrive. Oh God, drop floor now. We'll wait till the ferrites arrive and smoke test it before we get any of these ICs in, because well, bad things might happen. That's the thing. I'd like to just test the power rails and things, make sure everything's got ground and VCC on a board this complex before shoving these things in. But I'm very pleased because we appear to have programmed the most difficult part on this, I think. Well, difficult for me. And there we go, all cleaned up. So it could do with a cap on it, but anyway, it worked okay, didn't it? So I'll put that with the Lattice programmer and put that away until it's next used. Hopefully not within this video. Now I have ordered the right resistor array here, but you know what, I'm not even going to bother putting the right one on, because it's a 1K and it needs to be 5 pin. I've got some 1K 6 pins, so I trimmed the pin off and I've just sat it a millimetre above the board. So the pin that's cut off won't inductively couple to the trace running below it, and that's going to be fine, so it'll do the job. There's just one or two, I think there's one more resistor I need to see if I can do the same thing with on this board. I think it's like a 4K7 where you need an 8 pin, and I think I have 9 pin ones, which is really annoying. Alright, some ferrites have arrived. I don't think these are the majority, I just these like 1 or 2 here. And they're from DASIKeys.net. The interesting thing there is the domain is www.dasikeys.net, and then it says email address dasikeys@yeah.net. What's wrong with using dasikeys.net for your email? Why have you got a yeah domain? I don't know. That's a good sign, isn't it? Part number CBM. There we go. It was designed for this board. What those are, I think they're 30 ohm actually. You're supposed to have, I think it's 48. I couldn't find 48. It's going to be fine. They're rated at like 6 amp or something, I think. I think it's the main ferrite. I don't know. I need to try and find it on here now. Yeah, these ones are the 6 amp ones. So we've got 5 of these. So this is what I reckon is going to be used to connect a power rail up somewhere. Probably going to be the ones down here, I would suspect, on the power connector. We might actually be able to do some level of testing after this, after I've confirmed what all the other ones do. I mean, you've got loads like this, L. Those are all just passing the connections through filtering. And likewise, an absolute ton of them, all down here on these connectors. So those aren't going to be for power rails. There's the odd one like this here, that might be one of these ones. If it is, great. That means this is going to have power, and the things around here may have power. So, yeah, the majority of them I don't actually need to wait for, I don't think, provided we have 5 volts coming across here, and provided the odd one that's in places like that is doing what I think it's doing, and it's one of these ones. It would make sense, because there's about 4 or 5 like that. It's going to be these, isn't it? I reckon a couple of them are going to be used, 3 of them are going to be used here, 4, and then 1 somewhere else that I can't quite see. And actually, the first ones are on the floppy power connectors. I think 4 of them go there. Yeah, so as I look at my part numbers here, cheat sheet, L100, L101, that's those 2, 102, 103, there we go. Oh, I was hoping they're going to be for the main supply rails, they're not, they're just for the floppy power connectors. I mean, I've got that many of these, I could fit these all over the place. Mind you, it's 30 ohm at 100 megahertz, this is how these work, so actually you probably measure it, and it's probably at like almost a short. Let's just do that on the meter, because that's how ferrites are worked out, you know, or sized. It's a resistance at a frequency. So if I do a beep test on this, there you go, you get a beep, look, dead short. Put it on the ohms test. I mean, I could use these everywhere if I wanted. 0.005. Bear in mind there's some resistance on these, I've put this together. 0.005. There you go, so it's a dead short. So when you don't be under the illusion if you buy 30 ohm ones or 48 ohm ones or whatever you think it's going to put some resistance on that rail. It isn't. It's a resistance to frequencies. Yeah. So when you get 100, I think it's at 100 megahertz for these. When you anything around 100 megahertz, that's going to act like a 30 ohm resistor. Higher is better. So 48 would have been better. But you know what? There's no 100 megahertz on here at the moment. Things may change when you get the 68060 thing here and run that at 100 megahertz, yeah, because you may get, I don't know, some harmonics or something like that might just help a bit, but to be honest, you're probably not going to notice any difference between a 30 ohm and a 48 on this board. And you know, actually, I'm going to fit a load more of these on here, because the other ferrite beads I've got are just like 0 ohm ones, you know, straight ferrite bead, cheap as anything, cheap as chips. I think I've got like a couple of hundred of those coming, useful for all sorts of builds, but it's just, that's all it is. It's just a generic ferrite bead. It's not going to have the 6 amp rain here, and it's not going to have the 30 ohm resistance, impedance at 100 megahertz. So I actually think certainly for the key ones we need here. So like power rail here, I'm going to get all of those with those inductors rather than straight ferrites. And any of the ones that connect power rails, there's one here for the ports, look. And that's how that one was used. The one up here on its own, not going to have keyboard just for now until the general ones arrive for data and clock. But like the ones down here, again, for all the directions, no worries, just normal ones on those 0 ohm. But this one here, yeah, in between the two ports is for the power, the 5 volts of these. So I'm going to stick one there. So actually I could fit a dozen or so of these on here now. We might actually be able to power test it, you know, smoke test it effectively, see if everything goes up in flames. And I just think these are a better choice than just a straight 0 ohm generic ferrite bead. Yeah, there's the ones on the main power. Don't underestimate how hard it is to get them nice and straight and working in an area you've fitted components to already. So exciting times. I'm at the point where I feel like I should get the power connector on here, and you can argue the best way to do it is without any tips on it to start with, but we'll do some measuring around first. So it's going to go on this way, like that, according to the marking on the silk screen. So let's get that on. Now I got the ones on ferrites here, and I put the same ones, these 30 ohm ones. One there, one up here for this, you know, for these two things. There's still some, there's 3 missing there, L34, 35, 36 for the scandable side. Not worried about that. There's 4 or 5 or 3 or 4 missing from here for the audio section. There's some missing for the keyboard. All the ones missing for the ports. We have got the ones missing for video, so we can't do any video tests. No point sticking a Denise or an Agnes or anything at this stage. I'll wait till I've got all those in. And the ones for the composite, and some up here, I think, for the that produces the VGA out, by the way. That's really clever. I didn't realise that looking at the schematics. You don't need your own cable with a VGA HUD. They come out of here. You just need a cable that goes from, you know, from the 8-pin DIN there to your VGA. We need all the ones for the ports, so again, we can't do any diagnostics. Even if we could get video, we haven't got video. So, and we've not got the hybrids on there, and I'm reluctant to start soldering those things on, so all of these inductors are on at the back end. But what we can do is solder that on, do some connectivity tests to all the 7.4 series and stuff on there, all the chips, to make sure we do have 5 volts and ground to everything. And then we can try and power it and just see if we've got the voltages in the relevant places. And you know, depending on how you build a board, you can do some of the checks we're going to do in a minute, you know, at an earlier point. So in other words, if I'd focused on getting the power components onto this board at the start, I could have tested various things, including clocks, as we went along. So we're going to do that as well. Once I've got this mounted, I will measure the, we'll have a look at the CPU and FPU clock speed, because I'm curious on the two option, you know, resistor settings there, you know, depending on what you want. I think half the CPU clock, and I don't know, it's just, I'm just guessing based on what I saw with the 7.4 series underneath, you know, 7.4 AS74 I think it was. So just making sure that's nice and straight and flat and square. Yeah, and you can see it is. And I'm sure it's the right way around because, well, I wired my wires that way. So if it's not the right way around, it just matches my ATX adapter. We covered that in a previous video, there'll be a link to that top right. Alright, got the multimeter on continuity test here. These are the checks you would be crazy not to do if working on something like this. So let's just confirm. So as this goes like that there, 5 volts is the second and third pin from the right. So let's just see if those are joined to each other. Yep, they are, that's a good sign. So we know our cable's right. And then if we check from there to, I don't know, one of the 7.4 series down here, where's pin 1? So that's right, that's the uppermost pin. Dead short, let's check the ground. Nope, that's good. 5 volts pin, again, hang on, VCC, dead short, ground. Nope, just some resistance. We can test for the SMD ones here. VCC, VCC, nothing to ground, nothing to ground. You could do these sockets here. I'm not going to test with those in at the moment anyway, and to be honest, those are definitely the right way around. Well, according to the silk screen, these scales here, so it's the upmost pin, just like 7.4 series. They're all good. Yeah, nothing there, nothing there. This is a ground pin, just like 7.4 series, nothing there. So far everything's looking good. Let's go right round really and just check everything. You see we've got no 5 volts. Oh, hang on, it's because that's not the 5 volt pin. There we go. Yeah, the orientation shifts on these. 5 volts, ground. I am waiting for that 7.4 series there. It's just like an address decoder. It's like a A bit like the 6888 or 688, like a magnitude comparator. It's a bit like that. They're using it for the address decoding on the IDE here. Hang on. And of course, it's a good idea to do this. Just make sure you've got your chips the right way in, because otherwise you may kill one of your chips if it's around the wrong way. So everything is good here so far. Not going to bother testing those sockets because I've not got those chips in. That's not 7.4 series. I think we tested these, didn't we? Maybe we didn't. Oh, that's not 7.4 series. I mentioned there's lots of times where you've got ferrites. Sometimes those ferrites can be feeding a supply to a certain section of the board, and if you're not fitted it, well, that board's not going to have no 5-volt rail. And sometimes I've seen people use ferrites on the ground rails as well. I don't know whether that's a good or a bad idea, to be honest. You might want to do it where you separate, say, audio, analog ground from digital ground, maybe. Well, not really separating, but trying to create some impedance between them, just a little bit that high frequencies can't affect things. I don't know. So, I'm quite confident. Let's check these ones at the back here as well, just according to the other ones. I mean, if it's joined to here, it's joined there, if you see what I mean. Yeah, the grounds are joined up alright there. 5 volts are alright. I could just go around and just check all my grounds, maybe. That might be a sane thing to do. You know what, I'm confident the grounds and 5 volts are all connected up for most of the stuff. All the stuff I've quickly checked there. What else have we got? And then you've got 2 grounds. Let's just leave that there, that connects to test. So we'll go from the 5 volt to 5 volt, we know those are joined. And then from 5 volt to ground, yeah, we've got resistance, another ground, resistance, and then we've got 12 volts, resistance, and then we've got minus 5 volts. And there's nothing on there at the moment. That might be because we're lacking some inductors somewhere. The only thing that's going to be using minus 5 is that, I think, the TLS, and I suspect it's going between minus 5 and plus 5 on the audio, which is why we've got another op amp over here, because I was like puzzled by this, looking at it, going, hang on a minute, we've got the TLR084 here on the audio out, what's this? What's this over here? And we've got 2 caps, and it's an audio op amp, it's an LM339 or something. So I'm like, maybe that's doing the reset, now I think about it. Maybe it's not an op amp, maybe it's a comparator or something. 339. Yeah, I bet that's doing the reset. Because thinking about it, where's the reset coming from on this board? I haven't fitted a 555. So, yeah, ignore what I'm saying. Those aren't for audio. I actually think that's the reset circuit, maybe. But I could be wrong. I need to look at the schematics to confirm that. If I'm right, I'll stick it up there to the top somewhere. Or wrong. We're obviously missing some stuff at the back here. We're missing the 1488s, 1489s, the 06. Yeah, we've got the hybrids to fit. We've got IDE connector, floppy connector to fit. A lot of stuff still to go on, really, but all small bits. So I actually think we should, I'm just thinking about this, yeah, I think we should power test it and just see what happens. One of these caps could go up, we could get short, one of these could go up. This is a reason to test it without your 7.4 series. And the RAM, this is the other thing, you should test the VCC on the RAM, but you know what, according to the silkscreen marking, which I now can't see, yeah, those are on the right way, but I mean we can finger test things to make sure nothing's getting warm. And I guess doing it this way before we fit all the customs is the safest thing to do, really. Right, so power supply on the bench, power supply plugged in, power supply is off. Plug the ATX adapter in here, making sure I get it the right way round. So let's just quickly switch it on or switch it off. Just, I'm going to close my eyes, hang on a sec. I'll put my hand in front of my eyes. Ready? Nothing. It's not switched on. And what I mean is it's not switched on there, so we've got 2 switches here. Hang on, I'll switch it on there. And I'll point you the board in case it explodes. I'm switching it on. 3, 2, 1. Well, no immediate explosions. Switch it off. I just have a feel around, just to make sure nothing had gone nuclear as a result of that power on. And no, all seems alive, strangely enough. Right, let's give that a try again and measure from I'm assuming the ground, this is a ground here, then let's just check there. 5 volts, yeah, I'll show you the meter, hang on a sec. Just put that there. And we're going to test the clocks in a minute, assuming we don't find a problem before that. You can see that 5.02. So we've got 5 volts, just having a probe around on some of these chips. 5.02, 5.02, 5.02. That's a bit low, isn't it? Oh, that's the real, that's the, what's his name? Clock chip. 5.03. Yeah, so it seems alright. I'd be tempted to leave that on for 10 minutes and see if anything explodes, cap-wise. But you can speed up that process, you know, of checking that by, you know, just having it on for a bit like this, switch it off, and then just have a feel around. And you can smell things generally when they start heating up, you know, like if something is going, you know, it's the wrong polarity. You'll know about it fairly sharpish. So let's get the scope out. I want to scope here. I want to scope the CPU and FPU clock and these things here, because we'll start here, because I suspected, as I mentioned earlier on, that one of these is going to give us 50 top resistor, and I reckon the bottom one that's not fitted is going to give us 25. Right, I'll tell you what I'm probing as I'm probing it. So I'm probing the top, that resistor that's fitted, the right hand side of it, and you can see there 50 megahertz, and then it's an optional thing. So this, the right hand pad there goes to the right hand pad down below, so this is the bottom resistor, it's a right hand pad still, 50, and I was confused going, oh, why is it not 25? It's because that resistor's fitted, yeah, you both of the right hand sides of them that go out to the FPU are both joined up, so this is joined to that resistor we've got fitted, but the left hand side of this, yeah, is not, there's no resistor there at the moment, and as you can see there, 25 megahertz, there you go, so that 74AS74 is doing a divide by 2. So on this Rev 4 board here, this undocumented resistor, yeah, I was like, what's your fit there? It's not on the schematics, it's not on the bomb, it's nowhere, it doesn't exist. Yeah, on the R4 here, that's what that is, it's optional. If you fit the resistor there instead of in the top position, you get 25 megahertz over here. And I'm not going to show you, but I think it's somewhere up here from memory. Yes, it is. That's 50 at the moment. If we can't run it that fast with the 6882s I get, I'll just swap that resistor over to the other position. But we've proven a few things there. We've proven now the flip-flop on the other side is dividing by 2, and we've proven the 50, well, 3 things. The 50 megahertz crystal is working. 2 things. I don't know where I got the third thing from. The other thing I could do is just check this crystal is working. And there are a few components nearby there. There's an inductor. Let me just check that. Maybe the crystal, the frequency, you know, the clock is going through that. I don't know. Let's have a look. Yeah, I'm getting like harmonics or something on that. That is weird. No, that's working. That inductor there is showing 28.3754 megahertz, which shows it's this. Yeah, I think. Yeah, 28.375 megahertz. So we know that's oscillating. These are good things. We know that the clocks are there. We know the voltages are right. Nothing has exploded so far, which means I think my polarities on all the caps that are fitted are good. Yeah, I'm just, you know, and you can check temperature like this, just check. If one of these is hot, you know, it's the wrong way around. But they will explode and burn up short really, really quick if they are the wrong way around. So, yeah, I'm very, very pleased. Things are moving in a positive direction. I just wish those other inductors had arrived today, because if they had, we'd now be actually, in the next stage, get those inductors in, and then maybe get the customs in and try actually booting it, see what happens. And maybe something else to point out as well is, you know, there are something I just thought of. When you test something like this without anything actually clocking things through, in other words, no CPU, things are just going to sit in a state, aren't they? You know, so like, I don't know, and you can get oscillation maybe, because, you know, this is not driving anything. So that you might find the data bus, if you start to go up the data bus, you might find it kind of oscillates a bit. It's like glitching a bit because there's nothing actually driving anything. Yeah, you haven't got the CPU installed. I can't imagine that being a big problem testing it for a period of time, but you will get oscillation going on where a signal, you know, an input, something is floating somewhere. Yeah, it'll just flip one way or another. We have got some pull-ups and things, but not all the pull-up resistor arrays are fitted. We've still got 1 or 2 4K7s, I think, that I'm waiting for, but one relates back here. I forget where it is now. Yeah, it's something to do with the port up there. I think, or the keyboard input, and then the other one is all the way down here. Those are the only two resistor arrays I'm waiting on. And I suspect we might be able to test without those. It might work. I don't envisage either of those causing us a huge problem. Because I think this is just the 157. If anything, we might find the controllers a bit glitchy when we first test it if we haven't got that resistor array. Right, I'm getting desperate again. Just spotted another resistor array that I haven't ordered. And I swear to God, the wife will explode if I stick anything else on the credit card for this board. Every day I'm like, I'm not spending any more now, I've spent all the parts, got all the parts, next day order another part. There. I've ordered all the parts now, no more parts needed. I swear I've got all the parts now, I've double checked everything, I've got all the parts, and then I spot resistor array. Again. I already ordered some more resistor arrays this morning. So anyway, I've got a 470 ohm there that I think came from a 2000 actually. It's 8 pin, it's not 9. So there's a common pin on these, and basically you've got either 8, you know, in this case here, sorry, 7. Hang on, is it 7? Let's just measure these. A 9 pin one will give you 8 resistors. So if I measure from the common pin to that pin, you can't say it, 470, 470, 470, 470, 470, 470, 470. Yeah, so you've got 7 470 ohm resistors. Now, bear in mind that's a weird amount, isn't it? Because 8-bit, 8-bit bus somewhere, yeah, pull-ups, pull-downs, whatever. You want 9-pin one, so quite why we've ended up with how I've got an 8-pin one here, I don't know. Maybe 1 pin wasn't important somewhere. Anyway, so I can solder this on with its pin 1 marking in the right way round. Right, that will do for that. Let me go and get one 470 ohm resistor and some heat shrink. Budget UK, back with the heat shrink here. I'm going with blue, just because, won't it look nice with blue? At least it'll be a coordinated, colour coordinated bodge. But someone might not even notice it. Somebody who ever buys this in future when I'm dead and buried might be, hang on, I'm trying to think the colour code now. Yellow, purple, black, that's 4.7 ohm, isn't it? Yeah, it is, it's got to be yellow, purple, brown. Yeah, good luck trying to find yellow, purple, brown in this container of 100 million different resistors. And I said arrays there, I've got arrays on the brain. If we're really lucky, I might find one of the 470 ohms that I took off the 500 plus, because, well, if you saw a previous video, you'll know that I took all the resistors and stuff off it. So if you don't live in a shoebox like I do, then you can have component trays on your walls. I mean, I do have like 3 of them, but they're full to the brim. So when it comes to resistors, I have a drawer of resistors that are less than or equal to 1k, and then I have 2 that are over 1k. So you can imagine the fun games that I always have trying to find a resistor. To be fair, more often than not, I spot them really quick. You know, once you work out the colours in your head, so in this case yellow, purple, brown, it then just becomes a trivial task, really. I say that as I'm spending ages trying to find it. There must be one in here. It's a miracle. Yeah, out of about 500 resistors are there. There you go. Yellow, purple, brown. And it's round about now that I doubt myself and think, is it brown or is it black? No, I'm sure black's a 0 and brown's a 1. Let's be honest, it wouldn't be one of my builds, would it, if it wasn't bodged in some way. So, furthermore, I'm not even sure if this is the right resistor to go on here, because on the board it says RN1, and there's something that just looks like maybe it's a tiny little bit of a 4. I don't know. But next to it is R12 and R13, so I'm like, it's got to be R14, because I haven't found another one that is R14. So again, you know, there's an element of guessing going on here that is R14. So I hope it is. There we go. That's not looking bad at all for a bodge. Right, let's just check it together. So I believe the pin 1 is down here, so let's check. 470, 470, there we go. So that should do the job. And yet again, the video is getting a little bit long. So in the next part, if you could come back and join me for that, right at the start of it, we actually managed to boot this. And there's quite a lot more to do to this board. And there's obviously a lot of stuff to test on it functionality-wise. Anyway, I do hope you found the video interesting. If you'd like to support the channel, please see the Ko-fi and Patreon links down below. Every donation just means we can keep doing videos like this, so I cannot thank you enough for your support. Thanks very much for watching. I'll catch you in the next video.